revolutionize the banking transactions in India. The robust digital public infrastructure DPI has over the past 1 decade has transformative impact on India, extending far beyond the financial inclusion, and it is one of the best globally. So, as Pooja highlighted, we have already completed 4 days of NASDAQ in last week in the southern part of India. And Bangalore team last week has now passed on the baton to Mumbai, and I'm very, very happy to take it forward from here. Once again, good morning, everyone, and let's begin the day. So, I can certainly say that we have a very exciting day ahead with us, wherein our eminent speakers are going to talk about quantum computing, innovation, impact of artificial intelligence on our lives, and also sectors like BFSI, manufacturing. Mumbai being the financial hub of India, we have some interesting sessions lined up around Web3 in banking, FinOps, and security in finance. One of the key feature of NASDAQ being tech in action, and under this segment, you will see how AI and ML is impacting some of the smart city initiatives in India. You can also see some drones in action in the later half of today. And also some of the fascinating experts that some of the renowned scientists are going to conduct over here for us. You will also see some couple of brilliant speakers who have overcome their life's adversities and challenges, and they are also now guiding their peers. You will get to see how important the role a technology is playing on the economic growth of India, and some interesting discussions about how some of the startups have really scaled up, making all of us proud. And last but not the least, for all the sports lovers here, we are going to see a candid chat with Padma Shri Dilip Vengsarkar in the latter part of the day. So I look forward to have this insightful day ahead with all of you, and hope that you all are able to have a lot of learnings here and get the opportunities to interact with your industry peers. So thank you once again, all of you, and enjoy the day ahead. Pooja, over to you. Thank you.
Thank you so much, Vijaya, for the warm welcome and summarizing this entire day for all of us. Next up, the topic for the next session is Brain, the catalyst for tech's future. Human brain is one of the most versatile, energy efficient machines ever created. A deep understanding of brain's inscrutable algorithms can help technocrats use the human brain not only as a validator, but also as an inspiration for their work. An understanding of the brain will also help improve the adoption process of innovative technologies among its end users. He is the chief evangelist of Fractal and chairman of Final Mile Consulting. At Fractal, he's playing the new game that is emerging at the intersection of human and machine intelligence. He's driven by the belief that the more we understand the inscrutable algorithm in our brains, the better will be the technology we develop for our machines. Please put your hands together, ladies and gentlemen, as I invite Mr. Biju Dominic, co-founder and president chairman, Final Mile, chief evangelist, Fractal Analytics. A huge round of applause. Thank you. Over to you, sir.
Hi, good morning, everyone. Let me begin with a simple question. And the question is simple: who invented telescope? I know even before I could ask the question, you said, I know the answer. Galileo. But the truth is, Galileo did not invent telescope. It was invented by the Dutch spectacle maker Hans Lippershey. And 2 years after it was invented, because by then it was a big hit across Europe, Galileo heard of it. And then he asked Lippershey to make one for him. And all that I think Galileo did was to take that and start looking at using that and look at things in a different angle. And that's all what Galileo did. Today, I'm going to talk to you about another instrument, an instrument that has been in the making for the last 600 million years, and then requesting you to use that instrument or use that instrument to look at things around you or the work that you're doing in a slightly different angle. I know when few years back, when this competition happened between AlphaGo and Lee Sedol, people said, wow, here is the competition between the machine intelligence and the human intelligence. And on the second game, on the 37th move, when AlphaGo made a move, all the commentators of Alpin who was seen or watching that game said, oops, what a stupid move the machine has made. Because even amateurs know that if you make that move, there's no way you can win the game. But end of the game, second game, AlphaGo won that game. And that's when people looked at that move and said, oh, this is why the machine made this particular move. And as soon as that move was made, a lot of the enthusiasts of the machine intelligence said, Eureka! I think we no more have to depend on the human intelligence to do what we need. And the machine intelligence is now capable of doing things on its own. And so much so, I think Daniel Nasscom in his famous book said, machines are no longer riding on the coattails of human intelligence. But let's take a closer look at the game between AlphaGo and Lee Sedol. AlphaGo was using up about 200,000 watts, and Lee Sedol was using up about 13 watts. After the game, all that AlphaGo could do was still play only Go games. Lee Sedol did a whole lot of other things in life. Now, look closely at the human brain, and you realize in this time we heard the word sustainability once and more, and you will hear it again, the carbon footprints of all that we do. How can you make a machine that can work or do so many things like the human brain just at 13 watts? There's no doubt about it. There's no doubt about it. We, the engineers, have a lot to learn from how the brain is actually doing its activities. I think one of the other first people to really get into the intricacies of how the brain is all about was Hermann Hesse, German guy, in the 19th century. For example, he looked at how we decided to, decide what is a concave and a convex. What's on the left is all convex, and always the other is concave. Now, if you ask a graphic designer, they would say, "Oh, it's all about the shading." And as long as the shading is on the bottom, that would be seen as a convex object, and if the shading is on top, that would be seen as a concave. Now, that's how a graphic designer would interpret. But Helmholtz said, no, the brain has its own set of intelligence. And brain has certain evolutionary dictats, rules that are written in the brain. And in this case, the rule says there's only one source of light, and that source of light comes from top. And once that is decided, is based on it where our brain, decides what looks like a concave and a convex. Now, I know when the other day in the finals of the World Cup, when our friend ran all the way and took that catch and Rohit Sharma got out, people said, how did he take that catch? Now, if you ask a physicist, they would say, yeah, in order to gauge the trajectory of that ball, you would have had to have so many factors in consideration, which we know wasn't there in his head, in his brain. Now, Gerd Gigerenzer of the Max Planck Institute has done a fair bit of work, and he said, when someone is taking a running catch, they don't take any other factors into consideration except one. And he calls those factors smart heuristics. And he says all that the brain is looking at is the angle between him and the brain, and he just keeps it constant, and he runs around just to make sure that that angle is remaining constant. Smart heuristics. The truth is, right from Helmholtz to Gerd Gigerenzer to a whole lot of neuroscientists have actually figured out brain is super intelligent and is able to work at 13 watts because it has a lot of very interesting rules written in there in the algorithm. And don't you think if we understand those algorithms and bring that into the algorithms that we write for our machines will be far more energy efficient, will be far more efficient than what it is today? We all know the 60s and 70s when Minsky said, yeah, we know. And they brought in all the logical rules to actually rule the game. But somewhere in the late 70s, he just stopped. He couldn't move forward. But almost at the same time of 10 years later, there was another gentleman, Jeffrey Hinton. He looked at the whole thing from what angle? From the way the human brain functions. So much so, almost every alternate day or whatever, he used to come back and tell his kids, I figured out how the brain is doing that. So much so, the kids used to say, Papa, yet again. But all that understanding that he developed of the human brain, more so the visual cortex and the multiple structures that are involved in the visual cortex, he transferred it onto a paper, onto a thinking along with his others, and wrote that very famous paper on back propagation. Now, when you look back, you realize across technological advancement, I think there were people who really looked at the brain and tried to understand how the brain is doing that activity, have actually managed to create things that are really, really ahead of the world. But many times, I think technocrats, all of us believe that as long as we've created something technologically brilliant, that's it. That's wonderful. But the truth is, that's an old belief that if I make a good product, the whole world will come to my office and start buying the product. I know we all know that Beethoven wrote only 9 symphonies. He just started scribbling the 10th symphony, the initial notes of it, and he died. But just a few years back, the AI experts around the world and the music experts came together. They sat and they made the 10th symphony of Beethoven. And Beethoven experts listened to that and said, wow, this sounds very, very similar to any other symphonies of Beethoven. Great. Possibly the greatest creative output that AI industry has ever done. But do we hear much about it? Or just go to YouTube and do a 10th symphony of Beethoven and just look how many views are there. It's about 100,000. But just look at the 9th symphony. Millions, millions have listened to it. Many times we technocrats, I think, tend to believe there's a whole joy of creation. But the joy of creation is not joy of adoption. Whatever we make finally has to be adopted by our target audience. If it is not adopted, however great as the 10th symphony of Beethoven is, it's useless. Now, I know one of the greatest adoptions that have happened is smartphones. It's wow, everyone is almost, we know the amount of time, it's addiction. But what is the basic construct that drove the people who worked on smartphones? It was actually an experiment that was done among rats. And what are those? These set of rats were told every time you do the activity, you'll get a reward end of it. Certain reward. These set of rats were told whenever they try to press, once in a while they get a reward. And all that the scientists looked at and said is, now where will the rats continue to do the activity? What they found is people who've been given the certainty of a reward after some time stop doing the activity. But those rats who were given once in a while, they just continued the activity again and again and again. The whole area of the variability of reward. The thing that happens is only once in a while. But the whole dopamine that gets released and the loop it's creating in our brain is what makes smartphone so addictive. Now, I know each of you making a product of yours actually want to make your product so addictive. I know the question that each of you should ask is, whichever the projects that you're working on is, has the brain solved this problem before? Has the brain solved this problem before? And the chances are that the brain would have solved this problem before. So if that is so, all that we need to look at the brain, I'm not saying that maybe if you think there is something that you can replicate, replicate. But at least you can use it as to validate what you're doing. But many a time, like happened in the case of Jeffrey Hinton, Rumal Hart, Terence Evnosky, and the titans of AI industry today, it has inspired them to look at things in a way the world has never looked at technology so far. But to make that, my request to you is change the construct of your teams. We engineers think only in certain direction. Please bring in a multidisciplinary team, more so people who understand the brain, neuroscientists. Please bring them into your team. Now at Fractal, for example, I think we look at all our teams in a triangle: artificial AI plus engineering plus design and behavioral science. That's the construct of all our teams. Because we believe unless we have that multidisciplinary team, you don't really get inspired or you don't get inspirational, innovative solutions. Obviously, another, I don't know how many of you or any of you are in the world of education. Please change the curriculum of our engineering colleges. It's high time. It's high time our engineering students know that the most energy efficient, the most efficient machine that has ever been created in the universe so far is the human brain. And if you don't understand the functioning of that machine, then you haven't got a real right to say, I know all about engineering. Change the engineering curriculum. But as I end, I just want to remind you the quote that I picked up from Demis Hassabis. You know, DeepMind is the company that the world is sort of looking at. Look at his combination. Clearly, graduation or whatever in computer science, but look at his PhD. It's a PhD in neuroscience. And with the UCL, an institution that we also sort of, when I've been collaborating with, they just combined a creation, a combination of artificial intelligence and neuroscience. And that's what he said. Yes, each of us sitting here is actually sitting here to create a technology that is truly innovative, truly ahead of the world. If that is so, all that I would actually remind ourselves is the more we understand the inscrutable algorithms between our ears, better, better will be the technology we create for our machines. The theme for us is the future of technology. All that I would request is, as we are trying to build the future technologies, go back 600 million years back, an instrument that was being made for the past 600 million years. The more we understand that past, better will be the technology we create. Thank you.
If you have any questions, my team is going to come with the mic. You can raise your hands, please.
Thank you for the fantastic talk. So I'm curious. I mean, you are emphasizing that we need to understand the brain much better than we do, and this has been an ongoing exercise. Are there new, very different approaches which have started in the recent past to understand the brain? I mean, this whole idea of artificial intelligence is sort of based on what we think how the brain works. Of course, as you pointed out, the power requirements are very different, but they're also working in very different environments. I mean, where would you suggest that this research should go in order for us to make progress in this direction?
One is, of course, I think we should research more and more about the human brain, no doubt about it. But my own grouse is that a lot of what we know already about the brain, which has come in the last 15, 20 years. For example, to me, I think I'm giving a talk in Bangalore on this Friday on the same topic, which is that you can look at it, M. Zimmerman's paper clearly said of the 11 million bits of processing that we have, 11 million bits of processing that the human brain has, only 75 of them, just 75 of them work at a conscious level, which means 99.9999% of human processing happens at a level below our consciousness. Now, Zimmerman's paper came about in the 1960s. But to this day, we are just not able to accept it. And just about 3 weeks back, I think Robert Sapolsky's book has come in Determined, and which again said there's nothing called free will. But how many of us are willing to accept that? So the problem, Professor, is there are a lot of things that neuroscience is giving. For example, again, Antonio Damasio's work, which says there's nothing called a rational decision. All human decisions are emotional. Now, how many engineers will want to accept it? And that study was there. And this study was done about 2 years, about 20 years back. So the point is not that should we have more research on this one. This is the last 15, 20 years, there have been some tremendous findings about neuroscience. But are we willing to forego the status quo bias, which our brain has, and forego and say what I know so far about human behavior or about things are wrong, and there are some new learnings that are coming in. So are we willing to accept that? To me, that would be the biggest question. And let the research on the brain continue. And AI has a big role to help understand such a complex thing called the human brain itself. Yeah.
This is the last question. We'll have to take the rest of the questions off stage.
You talked a little bit about diversified team composition. Can you just elaborate a little bit more around that, and why do you feel that that is actually necessary, and if the skills that you have is enough for what you're actually looking forward to execute?
It's just purely because each is a expertise in itself. Like at Fractal, because artificial intelligence, I think they look at things in a certain way. Engineering, the back end of it is another job in itself. Designers and behavioral science people look at things in a different way. So you can't expect one person to have all this knowledge. So it's always good to have experts of each of those fields coming together and working as a team on the same problem. So each of them look at their strength, their problems. The designers look at the same engineering problem that engineers look at, the same this one from the data scientists look at. But when it triangulates or comes together, it's where you get some wonderful solutions.
All right, sir.
Thank you. Thanks a lot.
So if I can request you to please be on stage for one more minute. Thank you so much, sir, for such an insightful session. And like you mentioned, that the challenge is to let go of the conditioning. And the slide that you mentioned, which says marriage of brain and machine, if we intend to do that slowly and gradually, we will reach to a point of what he just mentioned in the entire presentation. So thank you very, very much. May I please invite Mr. Srikanth on stage to felicitate our first speaker of the day, Mr. Biju Dominic. Let's have a huge round of applause, ladies and gentlemen. Thank you, sir.